Road. Welcoming. Euro world. Welcoming. Welcoming. Good evening, Duben. Good evening. Good evening, Euro world. W's in the chat. Robson Green. You're welcoming everyone. So please, thank you everyone. So if you can share the live, please share. We move. Alright, so today we'll be rounding up our days on YouTube. So today we round up our days on YouTube. Thank you everyone for coming. Suliyat, welcoming. The King's Dealt vessel, welcoming. Choco Babe, Choco Babe, welcoming everyone. So today we'll be rounding up our time and our days on YouTube. So tomorrow, no, I'm not doing physics here. Even if I'll do physics, it will be on TikTok. Even if I'll come live tomorrow, it will be on TikTok. So yeah, so tomorrow we'll be moving to TikTok. So that's if I have the strength. I'll come live on TikTok. Tomorrow, same time, 9 p.m. Yeah, 9 p.m. So let's just talk about trigonometry. Then we call it a real time spent on YouTube. A real time spent on YouTube. So welcoming everyone. Yeah. TikTok, please. Yeah. Don't worry. So are we ready? Let's move. Let's march. So trigonometry. So the word trigonometry is gotten from 3 words, right? We all know that the word. Yeah. We are going to do it. We'll try and do it. Bearing and distance. We'll try and do it. Don't worry. We'll try and do bearing and distance. Probably we'll just solve one example. So the word trigonometry is gotten from what? It's gotten from 3 words. Trigonometry. Sure you get. So the word trigonometry, the word trigonometry is gotten from, the word trigonometry is gotten from 3 words. It's gotten from 3 words. Now, what are the first word? You all know the first word. Alright. So we all know the first word. What is the first word? Tri means what? Tri means 3. Then gono means what? Angle. Then metry means what? The study of what? What does metry means? Metry means the study of triangles. The study of triangles. So the word trigonometry is gotten from 3 words. Now, what are the first words? Tri. When you have tri means what? Tri means 3. Tri means 3. So you get. Then what does the word gono means? Gono means angle. Gono means what? Angle. Then metry means what? Metry means the study of triangles. Metry means the study. So now, good evening, Adedeji. Welcome. Good evening everyone. So metry means what? Study. Metry means study. So that's what metry means, study. Let's just say study. So in short words, what is trigonometry talking about? Trigonometry is what? In short words. So we'll just solve few things. I'll not go deep into it. In short words, trigonometry so is the study. Trigonometry is the study of three angles. Is the study of what? Three angles. So, are we all clear? Yeah, three angles study. Welcome in Eniola. Welcome in everyone. Yeah, Rita. So, good evening. Good evening. Peculiar. Good evening. Welcome in. So, let's just solve some things under this guy. So, I'm taking it one after the other under trigonometry. So, we all know that trigonometry is gotten from what? From three words. And what are the words? Tri. Tri means three. Gono means angle. Then metry means study. So, in short words, trigonometry is the study of what? Of three angles. Trigonometry is the study of three angles. So that is that about that. Now let's go to what we call Pythagoras theorem. Pythagoras theorem. If you don't know it before, please make sure you pay attention. If you don't know it before, make sure you pay attention. Yeah. So please, if you can share the live, please share the live, share the live, share the live. So we have just one question to solve here. Just one question. So then we'll move to SOHCAHTOA. We'll go to trigonometry ratios. So we all know what Pythagoras theorem is now. Should I still give you? Yeah, we all know what Pythagoras theorem is. They can't ask you to state the theorem in JAM. It's not possible. But let me just tell you what the rule is talking about. Pythagoras theorem states that what? The square of the longest side. Do you get? The square of the longest side, which is what? The hypotenuse. So that's the square of the longest side is equal to what? The sum of the square of the other two sides. That is just Pythagoras theorem. That is just all about Pythagoras theorem. So Pythagoras theorem, there's no need of writing it, but let me just give you. Pythagoras theorem states that the square of the longest side, is equal to the squares of the other two sides. So this is what Pythagoras theorem is saying. So now let me just give you a diagram. Let's say we have a diagram like this. Now look at it. So you can only use Pythagoras theorem in a what? In a right angle. You people are not talking. Or you people are following. Are you following? Make sure you are following. So let's say we are talking about what? Pythagoras theorem. We only use Pythagoras theorem in a what? In a right angle triangle. So you can say Pythagoras theorem in a right angle triangle states that what? The square of the longest side is equal to the square of the other two sides. Now look at it here. Look at it. Where is our longest side here? Let me label it A, B, C. Let me just label it A, B, C. Now this is our right angle triangle. Let me label it A, B, C. Now looking at it, you guys should talk. Which one is your longest side here? Which one do you think is your longest side here? Yeah, check. Which one do you think is your longest side here? I'm seeing people now. Amira, so you're here. Welcome in, Prince. Welcome in, Delight. Okay, C. So it means here is our what? Here is our hypotenuse. So it is called hypotenuse. So why the other two sides? So it's depending on the angle. Whenever there is angle there, the side facing your angle is always your opposite. But since there is no angle, let's just call this side our opposite and let's call this side our adjacent. Do you get? But when we get to SOHCAHTOA, we'll include an angle there. So in short form, what is Pythagoras theorem? Pythagoras theorem is saying hypotenuse square, the square of the longest side, you square the hypotenuse, equals to the square of the other two sides. You square the opposite and you also square the adjacent. So please don't forget this formula. This is Pythagoras theorem. Are we all clear with that? I have to be coming to the back to look at comments. Yes, see. So hypotenuse square equals to opposite square plus what? Plus adjacent square. Are we all clear? Should we move on? Are we all clear? If you can share, please share the live, share the live, share the live. So, if you can. Are we all clear? Should we move on? Chat, should we move on? Yes. It's only in row word that is talking. Have you people eating like this? Have you eaten? Okay, another. Okay, so we can move on. So, now let's solve one example. Let's just solve one example. Okay, blind. All right, Prince. All right, let's just solve one example. So, now we have a diagram. Let's solve one example. Just example. So it says find the value of x. Find the value of x in the figure below. Find the value of x in the figure below. Now look at it. We are given this diagram. You are given here as x, here as 5, and here as 4. Alright, so let's say we have this diagram, and here's our right angle triangle. Now, if you are told to look for what? Find the value of x in the figure below. Let's say you see questions like this in your JAMB. Let's say you come across questions like this in your JAMB. Now, we have 5 here, we have x here, we have 4 here. Now, the first thing you need to do is, when you are looking for one side, listen, when you are looking for one side and it is a right angle triangle and they ask you to look for one side, you can use what? Pythagoras theorem. Please take note of it. In the exam, if you are given a diagram and it is a right angle triangle, are you getting it now? And it is a right angle triangle. If you are given a diagram and it is right angle triangle, now, but they give you two sides. They now say you should look for the other side, one more side. Don't forget you are using what? You are using Pythagoras theorem. Are you clear? Are you clear with what I just said now? Do you get what I just said now? Do you all understand what I just said now? Do we all understand? Yeah, I know. So, do we all understand what I just said? Alright, yes. Alright, let's try and solve it together. Looking at this guy now, where is our longest side? Which one is our longest side here? Which one is our longest side? Looking at it. Which one is our longest side here? Which one will be our hypotenuse? What is our hypotenuse here? 5, right? So that will be what? Using Pythagoras theorem, this is what? This is hypotenuse square equals to opposite square plus adjacent square, right? So our hypotenuse here is 5 square equals to, so you know there is no angle there. So since there is no angle, we can either call anyone the opposite. Since there is no angle, so let's call our x our opposite. So that will be x squared. You know you square the opposite. So the opposite, let's call it x. Then plus what's our adjacent? 4. So that will give us 25 equals to x squared plus 4 squared will give us 16. So what do we do here? We bring 16 to this side. So that will give us what? That will give us 25 minus 16. When plus 16, when it crosses the equal sign, you need to change to minus 16. Equals to what? Equals to x squared. 25 minus 16 will give us what? Will give us 9 equals to x squared. So for us to remove square, don't forget that if you want to remove square, you square root. So what do? You know you have x squared equals to 9. So if you want to remove square, you square root. That will be square root of what? 9. So what will be your x? Your x equals to 3. And that's how you get the value of x. And that's how you get the value of x. Now, yeah. So do you get it now? Is there anyone that is here that did not understand what we just did now? Is there anyone here that did not understand what we just did now? Is there anyone here? Is this one clear? Is this one clear? You are just joining. You are welcome. Alright, let me come again. So if you are just joining, you are welcome. Now, the question says find the value of x in the figure below. Find the value of x. Now you are given this shape. This is 5, this is x, this is 4. Now, when you are given two sides to look for what? The other side, one of the, maybe the last side, you are using what? Pythagoras theorem. And what is Pythagoras theorem? Pythagoras theorem says the longest side is equal to the square of the other two sides. Now, what's our longest side here? If you look at this right angle triangle, our longest side is this. This is our longest side. So that's our hypotenuse. So you call it 5. But what is it? You are going to square that hypotenuse. That's 5 square equals to, since there is no angle there, you know, if there is angle now, you know the side facing our angle, we used to say is opposite. But since there is no angle inside this right angle triangle, so let's just call our x the opposite. So that will be x squared, because you square the opposite too. Then plus, what's the other side? 4. You square it also. So what is 5 squared? 5 squared means 5 in two places. That's 5 times 5. That will give you 25. Then equals to x squared plus 4 squared means 4 in two places. That's 4 times 4. That's 16. So what do? Since x squared is positive here, let's just take plus 16 to come and make 25. You know, when plus 16 plus this equal sign, it becomes what? Minus 16. So that will be 25 minus 16 equals to what? X squared. So what is 25 minus 16? That will give us 9 equals to x squared. If you want to cancel square, if you want to cancel square, what do? You square root both sides. If you want to cancel square root, what do? You square both sides. So since we want to cancel square, what do? We take the square root of both sides. So square root of 9 will give us what? 3. And that's how you get the value for x. So that is how you solve questions like that. Yeah, the 90-degree no, that's 90 degrees showing you that it's a right angle triangle. Do you get? That one is just showing you that it's a right angle triangle. That one doesn't mean angle is different from the right. This 90 degree I see is just showing that you can only apply Pythagoras theorem in a right angle triangle. So it's showing you that this is a right angle triangle. Yeah, that is just that about that. No. So that is just that about that. So are we all clear? Are we all good to go? Are we all good to go? So let's go to Soka 2. Are we good to go? Is this one clear now? Welcome in, Abdullah. Welcome in. Are we all good to go? Alright. So please screenshot, then we move on. Screenshots, then we go to Soka 2. That's trigonometric ratios. Screenshots, then we go there. Screenshots. So can I clean? Can I clean now? Thank you everyone for the tabs. Thank you so much for the tabs. Thank you everyone. Thank you for the tabs. Please share the live to your WhatsApp, to anything. Share. Can I clean now? No. You're welcome. You are just started. So take a screenshot first. Take a screenshot before I clean. Take a screenshot before I clean. So can I clean now? Okay, done. Alright. So now let's go to trigonometric ratios. Let's go to trigonometric ratios. Now on trigonometric ratios. Trigonometric ratios. Now, from this guy now, let's say we have a right angle triangle. Now, this is a right angle triangle. So let's call this guy A. Let's call this guy B. Let's call this guy C. So we call this guy angle A. We call this guy angle C. Then we call this guy angle B. Everywhere good, yeah. So hope I did not miss anything. Alright, so now let's say we have an angle theta here. So You know, if here is angle B, look at it though. If we call here angle B, if we call here angle B, this side here will be what? Will be small letter B. Let's call it small letter B. You know, if here is angle B, this side here will be what? Small letter B. Now, if here is angle A, this side here will be what? Small letter A. This guy here will be small letter A. And if here is angle C, this side here will be what? Small letter C. Do we all agree with me? Do we all agree with me? So, you know, if here is angle A, this side here will be small letter A. The side facing the angle is your small letter. Then if here is angle C, this side facing this angle is what? Small letter C. Then if here is angle B, then this side facing the angle is what? Is small letter B. Alright. So now let's derive our SOHCAHTOA from the word SOHCAHTOA. From the word SOHCAH. I know many of you have heard about SOHCAHTOA. SOHCAHTOA. Now from the word SOHCAHTOA. Now what does it mean? Okay, let's call this guy here angle alpha. So here is theta. Let's call here alpha. Let's call this guy alpha here. Now from the word SOHCAHTOA, what does SO means? SO means what? That will be sine theta equals to what? Opposite over hypotenuse. You know, when you pick sine, so for so now, it means what? That will be sine theta equals to what? What is O? O is called opposite, then over H is called what? Hypotenuse. So it means sine theta is what? Opposite over hypotenuse. Are we okay? Are you people following? Please, if you are not getting it, let me know on time. Are we getting it? You now have to come to the back to check the comment. Alright. You now have to come to the back. Are we getting it? Rudy, welcome in. Alright, correct. Alright. Who else again is not? Are we all getting it? Let me first know now. Are we getting it? Alright. Who else again? Let's see one more. Alright. So, sine means opposite over hypotenuse. Now, what is our opposite here? Opposite to this theta. You know, I told you that the side facing your what? Your angle is called what? Opposite. So, which letter is facing our angle here? Which side is facing our angle here? Peculiar, where are you not getting it from? Which side is facing our angle here? What will be our opposite here? What will be our opposite? C, right? Do you get it now? You know, this is the angle theta we are dealing with. So I said the side facing your angle is your opposite. So meaning that our opposite here is C over. What is your hypotenuse? Your hypotenuse will be what? What will be your hypotenuse? Your hypotenuse will be what? The longest side. That one does not change. The hypotenuse will be what? What will be our hypotenuse? B, right? Good. We are following. B. So please take note. So let's do for K. When you pick cos theta, that's called cosine. When you pick for cos now means what? This A is called adjacent over what? Hypotenuse. So it means for cos theta is what? Adjacent over hypotenuse. Do you get it now? For cos theta is adjacent over hypotenuse. So what's our adjacent here? What's our adjacent? Now let me tell you how you get your adjacent here. Please listen. What's the adjacent here? No. Adjacent. Is it adjacent? No, it's not B. Abi, is it the former one you are telling me? No. Look at it. Let me tell you how you get your adjacent. Okay. You have this shape. This is the shape you are looking at. This is the angle theta. This is A. This is B. This is C. Sure you get. So this is the right angle triangle. Let me remove this one. Let me remove this angle so it will not confuse you. Now, you know we are dealing with theta now. Let me tell you how you get your adjacent. You see, any side that contains your right angle, that 90 degree and the angle is your adjacent. It's called the adjacent. You know, for opposites, how do you know opposite? Opposite is the side facing the angle. Which side is facing this angle? This is this C. That's how you know C is your opposite. But any side that holds your 90 degree and your angle is your adjacent. Now look at it now. Which side contains your 90 degree and your angle? Which side? Tell me. Which side contains your 90 degree and your angle? Which side is that? Integration. Which side is that? A, right? Do you get it now? Talk to me. Let me know if you are following me, because it's not B written now. Look at it. The side that contains, I said the side that contains your angle, your 90 degree. Look at it. This is the side here now that contains your 90 degree and also the angle. Is this side, if you are picking here now, does this side contains 90 degree? No now. So which side contains your 90 degree and your angle? Do you get? So that is what? That is A. So it means my adjacent here is what? Since I'm dealing with this angle theta, my adjacent here is A. Then over what is your longest side? Your hypotenuse still remains B. Your hypotenuse still remains B. Do you get it? Your hypotenuse still remains B. Are we clear with that? Are we clear? So after this, we just solve questions and we fire on. Are we clear with that? Yes. Are we clear? Yes. All right. So let's go for tan. Let's go for tan. For tan, let's go for tan theta. For tan theta is called what? What is O? O is opposite over A is what? Adjacent. Opposite over adjacent. What is the opposite to your angle theta? What is the opposite to your angle theta? The opposite to your angle theta is what? What is the opposite to your angle theta? Thank you. C, right? You see that you're getting it now. So all these ones is just a way for you to get the diagram in the exam. That's why I'm explaining it. C over. What is now your adjacent now? What is your adjacent? Your adjacent now is what? A. Thank you. Your adjacent now is A. So that is just that about SOHCAHTOA. That is just that about SOHCAHTOA. How many of you remember one formula I gave you in differentiation? You know, I told you that another way of writing tan theta. Who can remind me? I said another way of writing tan theta. Who can remind me that? You know, I said tan x. I use x in differentiation. You know, I use x in differentiation. Another way of writing tan theta will not be what? Who can remind me? If you get it, I just one marker. No, it's not sec or prince. Hey, it's not cos over sine. No. Another way, I don't say the differentiation. You know, the differentiation of tan x is sec square x, right? But I'm not asking you for the differentiation now. I'm asking you for another way. You know, I made mention of another way that if I don't want to call Tinubu now, I can say Bola Ahmed. Sure you get. But his surname is Asiwaju. It's not sec over tan. Another way is sine theta over cos theta. You know, I said it that day now. That's sine theta over cos theta. Another way of writing tan theta is what? Sine theta. Welcome in. Or that. It is. No, I did not use our leader now. I didn't use our leader. But I'm just trying to. Someone suggested I should use him, but I did not use him so that you can remember. That's what I'm saying. You know, another way of writing tan theta is what? Do you remember? Oh yeah, check. Do you remember that I said another way of writing tan theta is sine theta over cos theta? Do we all remember this guy? Yes. Now. Alright. And just tell me sine over cos. If there's no need of writing theta, just tell me sine over cos. But we all remember now. So now let's check if it is actually true. Yeah, now what is our sine? Our answer for sine is what? What's our answer for sine? Our answer for sine is C over B. C over B. Then divided by, what is our answer for cos? Our answer for cos is A over B. Look at the mathematics here. Now that will be C over B. This is divided by A over B. You know that's divided and so let's write it like this. So that will be C over B. When you change division to multiplication, what happens? B goes up, A comes down. So what happens? B will go up, A will come down. So B cancel B. What do we have? C over A. Oh yeah, check. Is it the same answer for tan theta? Check. Is it the same answer for tan theta? Is it the same answer? You see it's the same answer. Do you see it now? Do we all see it? Yes. So you see that, so you see that another way, because we make use of it, oh, don't forget, we will make use of it. So let me explain it again. You know, another way of writing tan theta, if I don't want to say I'm calling you, you know, if I don't want to call you your first name, another way I can call you is your other name. If I don't want to call you your first name, another way I can call you is your what? Is your other name. But that other name I'm calling you does not mean that is your what? That is your surname. You know, that other name I'm calling you does not mean that is your what? Your surname. So it means that another way I can say tan theta, if I don't want to call him his first name, I can use his other name. And what is the other name? I can say sin theta over cos theta. That is the other name of saying tan theta. So look at it now, just to check, just to prove. What is sin theta? Sin theta is C over B. The answer we got for sin theta is C over B. Then it is divided by, what is cos theta? Cos theta is A over B. Now this is C over B. This is divided by A over B. This is division here. So when you change division to multiplication, you know what happens on the other side. B goes up, A comes down. So B goes up, A comes down. That is C over B times when you change division to multiplication. So what happens? Since it's times, B can cancel B. What do I have? C over A. Now check the answer for tan theta. Is it not still the same C over A? You see, it's still the same C over A. Do you get it? Thank you. Ikedel card. Thank you so much. Do you understand it now, Rita? Do you understand? Do you get it? Thank you so much, Ikedel card. Thank you so much. Do we all understand now? Tina, welcome me. Do we all understand? Alright, so that is that about that. So I'm just trying to give you some other formulas. Let me give you, welcome in, Tina. So, alright, welcome in, everyone. So now, that is just that about this plan. Now, let me give you other ones, just in case. You know, if you remember very well, I told you that what? Let's do for sec theta. You know, I gave you sec theta is what? 1 over what? Cos theta. You know, this is secant. It's called secant. So secant theta is what? Another way of writing it is 1 over what? 1 over cos theta. Do you get it? That is for secant. Now, take note of all these formulas. Therefore, cosec, that's cosecant theta. Another way of writing it is 1 over sin theta. So take note of all these formulas. So another one I will give you is what? For tan theta. You all know tan theta already. Tan theta is what? Sin theta over cos theta. Then we also have cot theta. Cot theta is cos theta over sin theta. So put all these things. These ones are called another expressions. So make sure you put it in your head. You will need it though. If you don't know this, you see this part like this. If you don't know it, if you don't know another name for it, you will miss it though. Please, I pray you will not miss it. So this are called another expression. Let me just write it there. Another expression. So if you don't know these guys, it will be very difficult to solve trigonometry questions in the exam, because the questions they will give you will be related to this guy. Do you get it? All right. So let's move on. So that is that about that. Now, let's do for there's no need of doing for angle alpha. If you want to do for angle alpha is equivalent to this guy. For sine, don't worry. Let's move on. Let's move on to questions. So let's move on to questions. Are we okay? Or should we do for angle alpha? Do you want us to do for angle alpha? Should we do for angle alpha too, so that you can know sin 30 and sine 60. Should we do 4? There's no need, right? Some people are saying yes. Is there need for it? Okay, if you want us to do it, it's fine. Let's just quickly prove it. But please make sure you know this ones in your head. Another way of writing tan theta is sine theta over cos theta. Another way of writing cot theta is cos over sine. Another way of writing sec is 1 over cos. And another way of writing cosec is 1 over sine. Please make sure you put this another expression. Make sure you know it by heart. Now let's do for sine alpha. For sine alpha now, let's just brush it. Then we'll solve the examples. Sine alpha is what? You know, sine is opposite over what? Wait, let's just do it. There's a reason why, so that you get it very well. You know, sine 30 is equivalent to sine 60. Cos 60. Sine 30 is equivalent to what? Cos 60. Oh, since there's no need then. Oh yeah, screenshot, there's no need. Screenshot. So, then I'll give you the 3 trigonometry identities. After I give you that, I'll give you the 3 trigonometry identities. Alright, there's no need. Alright, no problem. So, let's go to quadrant. But before we go to quadrant, let me give you these 3 trigonometry identities. These are the formulas you will need here. They are called trigonometry identities. So please don't joke with all these formulas. So the first one is what? There's proving for it, but there's no need. Sin square theta plus cos square theta is equals to 1. There's proving for it, but there's no need. But cosec square theta is equals to 1 plus cot square theta. Then sec square theta is equals to tan square theta plus 1. So these are the 3 trigonometry identities. Please make sure you put it offhand. You will need it too. We might not need it now, but we'll need it. So make sure you take a screenshot again. These are the 3 trigonometry identities. Put it in here. There's proving for it too. How we arrive at this formula, there's proving for it. But if you want me to do it, we can do it. But there's proving for it. So you can see that. Okay, let me just do the first one. Should I try the first one? You see, just know this. You see this formula you're seeing here. Just know it offhand. But let me do for the first one. Now you see that the first one says what? The first one says sine square theta plus cos square theta must be equals to what? Must be equals to 1. Please make sure you follow. Alright. So look at it. You know sine square theta is the same thing as saying sine theta all square. Then cos square theta is the same thing as saying cos theta all square. Is it not the same thing? You know when you have sine square theta, it's the same thing as saying sine theta all square. You know sine theta all square means sine theta times sine theta in 2 places. Sine theta times sine theta will give us sine square theta. It is called sine square theta. Good. Yes. Alright. Since you know that one. So what is our sine theta here? Look at it. What is our sine theta here? What do we get? Our sine theta is c over b. You square it. Then plus. What is our cos theta? Our cos theta is what? Our cos theta is a over b. You square it. Now, when you open the square now, this will give us c squared over b squared plus a squared over b squared, right? When you open the square. Alright, it's a right on. So you know that when you open the square will affect c, it will affect b. That will be c squared over b squared plus what? A squared over what? B squared. Do we all get that part? Do you all get the part? I just want to prove one, then we'll move on. Do we all get that part? Yes, alright. So we all got the part, right? So now what will be our LCM here? Our LCM is b squared. Then over, that will be c squared plus a squared. You know, b squared and b squared is 1. 1 times c squared is still c squared. Plus b squared and b squared is 1. 1 times a squared is a squared. Now, look at it. When you have a squared plus, when you have c squared plus a squared, Look at it from Pythagoras theorem. From Pythagoras theorem, you know your longest side here is b. That's b squared, hypotenuse squared, equals to the square of the other two sides, which is c squared plus a squared. How many of you agree with this? You know, from Pythagoras theorem, you know, it says that what? B squared, hypotenuse square is b squared. That's b, hypotenuse is b, is equals to the square of the other two sides. That's c squared plus a squared. We all agree. So it means if I have c squared plus a squared, I can still write it as b squared. So it means this c squared plus a squared is the same thing as b squared over b squared. So b squared over b squared will give me what? 1. You see that sin square theta plus cos square theta is equals to what? 1. Do you get it now? Do you see how sin square theta plus cos square theta is equals to 1? Do you understand? So that's just the proving. That's why I don't want to give you something you don't need now. But maybe later on when you get to university, you might come back and, you know, go through the stuff. But since this one now, if you can try and put the formula in your head, you are good to go. If you can try and put the formula in your head, you are good to go. So that is why sin square theta plus cos square theta is equals to what? 1. So cos square theta is equals to 1 plus cos square theta, and sec square theta equals to tan square theta plus 1. Once you know this one and you know this ones, you are good to go. Once you know it and you know that one, you are good to go. Please come again. From where? Is it from the proving? Is it from the proving? Peculiar, Amira. Is it from the proving? Is it from the proving? Yes, alright. Let me explain the proving again. You know, sin square, you want to prove this first one if it is true. Sin square theta plus cos square theta is equals to 1. You know, another way of writing sin square theta, it is sin theta all square. That's another way of writing it. Do you get? So, you know, sin theta all square means sin theta in how many places? It means sin theta in 2 places. That's sin theta all square means sin theta times sin theta. Sin theta times sin theta will go back to sin square. It is called sin square theta. You know, when you have sin theta times sin theta, it is called sin square theta, not sin theta all square, but it is called sin square theta. So it means this sin square theta, I can write it as sin theta all square. And this cos square theta, I can write it as cos theta all square. Now, what is our sin theta? The answer for sin theta here is c over b. Then you square it. Then plus, what's the answer for cos theta? A over b. Then you square it. The square will affect c, the square will affect b. That will be c squared over b squared. Then plus a squared over b squared. What do you do here? LCM is b squared. You pick b squared. B squared and b squared is 1. 1 times c squared is still c squared. Plus b squared and b squared is 1. 1 times a squared is still a squared. Then equals to. Now, this c squared from this guy here, if you use Pythagoras theorem says that what? Hypotenuse square equals to the square of the other two sides. That's Pythagoras theorem. So what is your hypotenuse here? That's the longest side. So what is your longest side? B. You square that hypotenuse. That's b squared equals to the square of the other two sides. What is the other two sides? C squared plus a squared. So it means this c squared plus a squared, I can say is automatically equals to my b squared. B squared over b squared will give me 1. That is why sin square theta plus cos square theta is equals to 1. So, and so on. Going further, you can prove this guy. You can prove this one also. But I'm not here for proving. That's why I said, just put it in your head. Sure you get. So I didn't mean your exam is a written exam now. We have to be doing those proving. But since your own is just put it. You see, with this another expression, make sure you need it. We will get to a point that you will need it. Do you understand now? Welcome in everyone. Welcome in the front side. Welcome in. Yeah. Okay, so that another expression. Just know it off. And that I've explained that one already. Another expression of calling tan is sin theta over cos. For cot is cos over sin. For sec is 1 over cos. While for cosec is 1 over sin. Just put that on your phone. So can I clean now? Good to go. Alright, thank you. So let's go to quadrant. I will explain quadrant in short form and we'll solve examples. I will explain quadrants in short form, then we'll solve examples. Then I will give you these sine angles to know offhand. I'll give you those sine angles to know offhand. So that is that about today. Okay, good to go. Alright. Are we ready? Can I clean now? Can I clean? Please make sure you are following me. Can I clean? Yes, peculiar. Alright. I can clean. I can clean. So, alright, let's go to quadrant. We'll talk about quadrant. I'll explain it in a short diagram. I'm not going to break it down. I'll explain quadrant in short. Just in one diagram, I will explain quadrant. In one diagram, I will explain the whole of quadrant. So please take it like that. I don't want to give you plenty things that you need to be reading. So I will explain quadrant in short form. So let's talk about okay. So this is how quadrant is. This is how quadrant is. Let me just draw it like this. So I just want to explain everything in short form. So I don't want to be writing notes so that you will not have to bombard everything. So you see here is called the first quadrant. What do I call it? So here is called first quadrant. Here is called first quadrant. Here is called second quadrant. And here is called third quadrant. Third quadrant. So if you can know this diagram here, and here is called fourth quadrant. If you can know this diagram, you will easily understand quadrant. You will easily understand quadrant. So, alright, welcome everyone. Thank you all for the taps and everything. So now let me explain it. So this is our first quadrant. Why this is our second quadrant? This is our third quadrant. This is our fourth quadrant. Now, don't forget that here, you know here is 0 degree, right? Do we all agree with that? You know here is 0 degree. Do we all agree with that? Right? Do we all agree? Please make sure you get this quadrant. It's very, very important. Do we all agree that part is 0 degree? Every word. What is Oh yeah. Do we all agree that is the starting point? You know now, you all know this kini now. Compass. You all know this compass now. You know when you hold a compass, I don't have compass here. You know when you hold a compass, this is how a compass looks like. Right? This is how a compass looks like. When you hold a compass, there is always what? 0. Here is 180, right? Do you get it now? You know the middle here is what? 90. You all know compass now. Shebi, you know compass. Good evening, good evening. Yeah, I'm coming to that one. We are coming to that one. Good evening, Favor. Yeah. You all know compass now, Abi? So if you see that this is just like a compass, just like as if this is the middle point. So it means here is my 0. What will be this side? Here will be 90 degree. So it means this side here will be what? 180 degree. Then it means here will be 270 degree. Then coming back here will be 360 degree. You see that this is just like a circle. This is just like a circle. Do you get it now? So it means here is 0 degree. You know, this is a right angle here now. Right angle. So here is 90 degree. So 90 plus another 90 will give us 180. 180 plus another 90 here will give us 270. Then 270 plus another 90 will give us 3. So you see that this is a right angle. This is a right angle. This is another right angle. This is another right angle. Why this is another right angle? So 90 plus 90 plus 90 plus 90 will give us 360 now. Do you all get it? Do you all understand it now? Do you get the point now? Do we all get it? Now I'm coming back. I have to come back and look at the comment. Do we all understand it now? Alright, yes, alright. So now this is our first quadrant. You know, here is from 0 to 90. So if your angle falls between 0 and 90, then that is on the first quadrant. Check again. If it falls on 0 and 90, it means your angle theta is still equals to what? Is still equals to that angle. Sure you get? Or let me just say that angle you are given is still equals to angle theta. That is that angle. So if anything falls between 0 and 90 degree, are you getting me now? So if anything falls between 0 and 90 degree, that is still your what? That is still your angle. Let me connect so that I will not be coming to the back, so that we can understand this part better. So that we can understand it better. Alright. So alright. So I can read everything from here. So now you see, if anything falls between 0 degree and 90 degree, that is if your angle falls between welcome back. If your angle falls between 0 degree and 90 degree, that is your what? That is your, it is still the same angle you will use. But now, what is positive on the first quadrant? On the first quadrant, all is positive. We call it what? All. All is what? All is positive. On the first quadrant, what did I say is positive? On the first quadrant, what did I say is positive? All is what? All is positive on the first quadrant. Do you get? So it means that what? Your sin theta is positive. Your cos theta is also positive. Then your tan theta is also what? Positive. So if anything falls between 0 degree and 90 degree, do you get? All is positive. You all get that one? Yes. So that is that about that. Now coming to the second quadrant. This is our second quadrant. Now if anything falls between 90 degree and what? And 180. If your angle falls between 90 degree and 180, how do you get the angle there? This is how you get the angle there. To get the angle theta will be what? Will be 180 degree minus that angle you are given. That is how you get the angle. What do I say? To get the angle on the second quadrant, how do you get this angle on the second quadrant? Don't forget you will not be given calculator. That's why you need this guy very well. And it will help you in physics also. Do you get? It will help you in physics also. So it means on the second quadrant, how do you get the angle? If it falls between 90 and 180, do you get? If it falls between 90 and 180, how do you get the angle there? It will be 180 minus that angle. That's how you get the angle theta. Are we clear? Do we get what I just said now? Alright, yes, Emmanuel, thank you. Thank you. Welcome in, everyone. No. Okay, for example, if you are given angle 150 degree, for example, angle 150 degree will fall on which quadrant? If you are given angle 150 degree, angle 150 will fall on which quadrant? Which quadrant do you think it will fall on? Oh yeah, one bone. Second quadrant, because it is between 90 and what? 180. Because it is between 90 and what? 180. So if you are given angle 150 degree, how do you now get the angle here? It will now be what? You will say 180 degree minus 150 degree. That will be what? 30 degree. So either it is sine they are talking about or it is cos. You will know what to do there. Do you get? So, but on the second quadrant now, on the second quadrant, what is positive on the second quadrant? Only sine is positive. What do I call it? Only sine is positive. On the second quadrant, sine is positive. Sine is positive. What do I say is positive on the second quadrant? On the second quadrant, what do I say is positive? Sine is what? Is positive. Do you get it now? Yes. So on the second quadrant, sine is positive. Why cos and tan will be what? What will happen to cos and tan? Cos and tan will be in what? So on the second quadrant, cos and tan will be what? Cos will be negative, right? Cos theta will be negative. So there's no need of writing it. But you shall understand. Cos and tan will be negative. Good. Coming to this part now, this is the part you have to be very careful. Don't forget here is 270 degree. Don't forget here is 270 degree. Here is 270. So let me extend it so that you don't mix it. Here is 90 degree. So now coming to this guy here, how do you get the angle here? How do you get the angle here? It is very simple. So for any angle that falls between 180 and 270, shey you get? Any angle that falls between any angle that falls between 180 and 270, how do you get the angle there? You get the angle by saying what? You get the angle by saying that angle. How do you get theta? To get theta will be that angle minus 180. You say that angle minus what? One is not 270 minus that angle. Don't make that mistake. That's where you should not make mistake. Don't make that mistake at all. To get the angle here, what do you say? Let me write it down so that you will not mix it up. Let me write it down. To get the angle here, it will be what? To get the angle theta, it will be that angle minus what? 180 degree. Do you get it now? Please don't make that mistake. On the third quadrant, how do you get the angle? It is 180. That angle minus what? 180. So for example, if they give me 240 degree, what is 240 degree? 240 degree will fall on which quadrant? Where will 240 degree fall on? 240 degree will fall on which quadrant? If they give me 240 degree, it falls on which quadrant? The third quadrant, right? So how do you now get the angle? So instead of saying 270 minus 240, don't do it like that though. Don't go and say 270 minus 240. Shey you get? Don't go and do it like that. So how do you get the angle? You get the angle by saying what? You get the angle by saying 240 degree minus what? 180. Then 240 minus 180 will give us what? 240 minus 180 will give us 60 degree. And that's how you get the angle. Do you get it? Do you understand it now? So please pay attention to this one very well. If it falls on the third quadrant, you say that angle minus 180. So now what is positive on the third quadrant? What is positive? How did you get 40? Where is 40? Where is the 40? How did you get peculiar 40? I said 240. I'm just using for example that if you are doing 240 degree, it falls on which quadrant? It falls on the third quadrant. So that will be 40 minus what? 180. So on the third quadrant now, what is positive? Only tan is positive. Only what? Only tan is positive. Only tan is positive. On this third quadrant, only tan is positive. No, it's not possible. It's only tan that is what? Positive. So coming to this guy, how do you get the angle in the what? In the fourth quadrant? The angle there is gotten by saying what? 360 degree minus that angle. That is how you get the angle. So the only one that is changed, the only one that changes is this guy here. So it is only that third quadrant that changes. So what is positive here? Only cos is positive. Only cos is positive. Why? That's how you know it as cast. Is it that you know it as cast? C-A-S-T. C-A-S-T. Or you know it as at. A-C-T-S. A-C-T-S. Do you get it now? What happened? G, what happened? G, what happened? So are we all clear now? Are we all clear? Alright, so please take a screenshot and let's solve examples. Please make sure you don't forget everything we have said so far. Please make sure you don't forget everything we said so far. It is blurry. Okay, I'm thinking so too. I'm coming. Is it better now? Is it better now? Or coming? Is it better? Alright, Tina, thank you so much. Alright. Alright, please take a screenshot. So that is all. Something we are supposed to solve for long. Yeah, is either you know it as cast, that is cos, all, sine, and tan. Cast, or you know it as arts. But make sure if you are knowing it as cast, is to start from the fourth quadrant. This is first, this is second, this is third, this is fourth. Please make sure you know it. Then we'll solve an example. Yeah, to remember it easily. You don't get the cos, tan, and sine. It means yeah, all is positive here. Both sine, cos, and tan, all is positive. If it falls on this quadrant, all. But if it falls here, only sine is positive. Only sine is positive. But if it falls here, only tan is positive. Only tan is positive. And if it falls here, only what? Only cos is positive. Only cos is positive. There's a reason for that. There's proving for it also. But we don't want to do those proving. There's proving for it also, but we don't want to do it. There's proving for it also, but we don't want to do it. So that is just that about that. There's proving for it, but we don't want to do it. So that is just that about that. Do you get it now? So there's proving for everything. Or do you want us to prove it? How do you know where it lands? It's by the angle. Do you want us to prove one? 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 Should we prove one? Or we should prove two? People are saying no. Maybe I don't understand. Prove all our no time, not necessary. Alright, so but if you want us to prove one, we can prove. Okay, let me just do one. So if you look at it, I'll just do two. Let me just do this and this. I'll leave this one for you. So if you look at it very well, this is the quadrant. Now, you see that if we are talking about this guy, this is the center now. For this guy now, let me do for first quadrant. This is second, first and second. Now, if you know, you deal like this. You trace it down. Abi? Now, this is the what? This is the hypotenuse. Let's call this one hypotenuse. So, let's call it x. Then, here is the what? Let's say here is the angle theta. The angle always make with the horizontal. So let's just call this place. Okay, let me call this place. Let's call this place A. Let's call this place B, and let's call this place C. Now, if you look at it, the angle always make with the horizontal. The angle we always make with the what? With the horizontal. Wait now. Let me just do it so that for better clarification. So if you look at it, the angle always make with the horizontal. So if you do for sine, what is sine? Sine is opposite over what? Adjacent, hypotenuse. Opposite over hypotenuse. Do you get? So what is sine now? What is your opposite here? Your opposite is what? Your sine theta will now be. What's your opposite? A over B. You see that it is positive. What happened? Yeah, I love it too. What happened? Error word. Which one is check the syllabus? Trigonometry is there now. Jump would ask that. I know now. I know they will not ask you for the proving, but I'm just trying to understand why sine is only positive here, why tan is only positive, and why cos is only positive. Do you get? Yeah. Thank you, Pat. What's this one you are explaining? Why only sine is positive here? Why only tan is positive here? Why only cos is positive here? How do you get that cos to be positive here? Why is it not tan? Why is it not tan that is positive here? Why is it not sine that is positive here? That's what I want to explain. So I just want to explain the two for you. Just the first and second quadrant. That's why I just want. They will not ask you the proving, no. Do you get? They will not ask you the proving. I just want to explain it for you. They will not ask you the proving. Do you understand? Alright, do you get it now? Should we continue? Alright, Emmanuel, no problem. Should we continue or should we leave it? Which one? We should continue, but alright. So you see that here now the angle. Okay, I should just leave it. Okay, we should continue. Since majority carry, let me just explain 1 and 2. Just 1 and 2. So you see that the angle will always make with the horizontal. Let's say here is angle theta. So for sine theta now, what is sine? Don't forget from what we started first. She gets sine is what? Opposite over what? Hypotenuse. What is the opposite? A over what? Hypotenuse is B. For cos, what will be cos? Cos will be what? Cos theta will be what? What is our cos? Adjacent. What's your adjacent here? Your adjacent is what? C over B. Then for tan, tan will be what? Tan will be opposite over adjacent. That will be A over C. Right? Do you get it now? You see that everything is what? Everything is positive here. Do you see that everything is positive here? Alright, so coming to this second quadrant, let's say we have something like this. We have our line like this. So when you trace it down, the angle we make with the horizontal, angle theta. Yes, angle theta. So coming to this place now, let's call this place, for example, let's call this place A, let's call this place B, let's call this place C. But you look at this, here is negative what? This C, this x-axis is the negative what? Negative x-axis. Do you see that this C is the negative x-axis? Can you see that C is on the negative x-axis? Oh yeah, now confirm. You know, from number line now, when you have number line, here is the positive y, positive x, negative y, negative x, right? Yes, in graph now, from number line, you know, here is the origin. Here is positive x, negative x. Here is positive y, negative y, right? It will be minus because it's on the negative. But this a, you know, this a is positive what? Y-axis. Do you get? Oh, no problem. Let me just do it. This is the second one already. That a is still on the positive y-axis. Then c is on the negative y-axis. So when you go for sine theta, look at sine theta. Sine theta is what? What is your opposite? A over what is your hypotenuse? B. Then what is cos theta? Cos theta is what? Adjacent over what is your adjacent? Minus c over hypotenuse B. Then what is tan theta? Tan theta is what? Opposite over adjacent. That's A over minus c. Do you see it now? Do you see now that if you see cos is negative, tan is negative? Which one is only positive? Oh, okay, working now. Alright. Do you see now? Do you see that it's only sign that is what? Positive. Do you get it now? So do you understand why it is only sign that is positive here now? Do you get it now? So you see that it's only sign. Just remove it. Alright. One bonnet, check now. Fix your network, please. So you see that is just how you can do the proving. That is just how. Blur and lagging. My net is not lagging now. So that is just how you can do the proving. So you can do the same thing for the K. Alright, so that is just that about that. So please, let's solve examples, then we'll move on. Can I clean this guy? Can I clean? Alright, so let me clean now. Then we'll go to questions. So let's clean, then we'll solve questions. Okay. So, let's try this guy. Without the use examples. So, without the use of calculator, the question says example. Without the use of calculator. So that is how they will tell you. Without the use of calculator. Without the use of calculator. Question 1. Question 1. Now let's say you are given coming. So let's say you are given sine 120 degree. So we'll be solving. I'll solve one, I'll give you one. Let's say you're given, alright, so please listen. Let's say you're given sine 120 degree. They say you should solve this guy without the use of calculator. But after this guy, I will give you some sine angles. You know, sine 30, cos 60, sine 60. I'll give you everything. Sine 90, cos 90, sine 45. I'll give you those major ones. So now let's say you're given sine 120 in the exam. Do you get? Now, there is no calculator to press sine 120. But how do you now get it? Now, 120 degree falls on which quadrant? Which quadrant does 120 degree falls on? Which quadrant does 120 degree falls on? Alright, so that's what we're doing now. Which quadrant does 120 degree falls on? You see that it's on the second quadrant, right? So now what do you do? Okay. What is positive on the second quadrant? On the second quadrant, what is positive? On the second quadrant, what do I say is positive? Sine, right? So what are we dealing with? We are dealing with sine also. So it means it will be positive. That will be sine. How do you get the angle in the second quadrant? You know it will be positive. Since we are dealing with sine, you also call it positive. How do you get the angle in the second quadrant? What do I say you do? You do what? That will be on the second quadrant. How do I say you get the angle theta? 180 minus that angle, right? Do you all remember? Yes, thank you. So that will be 180 degree minus what? 120 degree. So what are you going to have? That will give us plus sine. 180 minus 120 will give us what? Yeah, that will give us 60 degree. And what is sine 60 degree? Sine 60 degrees automatically root 3 over 2. And you pick the option. So I will still tell you how sine 60 is root 3 over 2. I will still give you those things. But sine 60 is root 3 over what? Over 2. Do you all get it now? So that is how you remember all these things. You know, when you are giving sine 120, you don't know sine 120. The ones we know are 60, 30, 45, 90. Sure, you get. So, oh yeah, if you have calculator with you, press sine 120 and press sine 60. And let's see if the answer will give you root 3 over 2. If you have K-show calculator, press sine 120 and press sine 60, and let's see if both answer will give you root 3 over 2. Let's check. It's in decimal, that's 0.86. Press root 3 over 2. Is it 0.866? Press root 3 over 2. It's because you are using all these, don't let me talk. They cannot enter you small. It's because, so you see it's the same answer, right? So that is just how you get the answer. But JAMB will not put it in decimal. That's one thing. JAMB will not put the answer in decimal. They will rather put it in form of this. They won't put the answer in what? In decimal. Do we all get it now? Okay. Are we all clear? So how do you get root 3? That's sine 60. I told you we are coming to that one. That's the next thing we'll do. That's the next thing. Yeah, excellent. Don't worry. We'll do one. So now let me give you this one to try. Try for this guy. Question 2. Try for cos 210 degree. Prove your root 3 over 2. We are coming to that now. If I start proving now, you'll be shouting, proving. You don't need it. These things are not something that is hard. We are coming to that one after. And that's the next thing we are doing. It's not about proving. It's something you can know in your head. Put it in your head. Sure you get. So that's how you can know all those things. But I'll do one proving for you. If I start doing proving now, it will be as if we are just wasting time here. So it's not about the proving. The proving is not the main thing. So what will it be? Cos 210, what will be your answer? Who can tell me the answer? Cos 210. Who can tell me the answer? Cos 210 will be what? Some people are still making mistake. And with all my amid. No. Most of you are making that mistake. Where are those that were here since now? Should I told you, where does cos 210 fall on? Where does cos, it's not 270 minus 210. Where does cos 210, which quadrant does it fall on? Oh yeah, don't worry, let's do it together. Which quadrant does it fall on? On the third quadrant. And how do you get the angle on the third quadrant? Don't forget, I said, how do you get the angle on the quadrant? It is not 270 minus that angle. Don't go and make the mistake. It's not. I said it is that angle minus what? Minus 180. That's what I said. Don't make the mistake. So I said it is that angle minus what? Minus 180. So, but it's first on the third quadrant. And on the third quadrant, what is positive on the third quadrant? On the third quadrant is not 4 to 210 now. 210 is it up to the third, fourth quadrant? It's not up to the fourth, Eniola. What is positive on the third quadrant? Tan, so it means cos is what? Cos is negative. That will be minus cos. You call it minus cos. Minus cos. So how do you now get the angle now? It will be 210 minus what? 180 degree. It will be 210. Don't go and say 270 minus 180. Do you get? So that will give us what? That will give us minus cos. 210 minus 180 will give us what? Will give us 30 degree. And what is cos 30 degree? I told you sin 60 is root 3 over 2. Why cos 30 will be what? Will be minus root 3 over 2. You know, cos 30 is equivalent to sin 60. Why sin 30? Sin 30 is equivalent to what? Sin 30 is equivalent to cos 60. So that is that about that. So we are still coming to that proving. We are still coming to that. So it's only tan that is positive. So it means the sign, the cos will be what? The cos will be negative. Shall you get? Why is it minus cos? It falls on the third quadrant. When it falls on the third quadrant, what is positive on the third quadrant? You can quickly just sketch it. Shall you get? When you sketch it on the third quadrant, it is only tan that is positive. It is only tan that it is what? That is positive. So when tan is the only one positive there, it means you are not cos, it will be now negative cos. So if you have calculator with you, press cos 210. Let's know the answer. Cos 210 will give you minus 0.86. Press cos 210 if you have calculator. Press cos 210 if you have calculator. What is the answer? Is it the same? Press cos 210. It is not that one. Maybe you were here when I was drawing the diagram now. Maybe you were here when I was drawing diagram. I made mention of that third quadrant. I was even repeating myself. I said when you get to the third corner, it's not 270 minus the angle. So now press minus cos. You see that we have to put minus there. Press minus cos 30. Don't press ordinary cos 30. Put minus in front. Press minus cos 30. Is it the same answer? You see that minus cos 30 will give you minus 0.86. Sure, you get it now. So you see that the answer is still the same thing as cos 210. But we don't have, you might not know the cos 210. That's why you have to break it down to the smaller value. Do you get it now? So it's the same thing. But if you don't put the minus, you see that when you press ordinary cos 30, it will give you 0.866. Do you get it? If you don't put the minus, you see that it will not give you minus. Sure, you get it? That's why you have to know all those things. So don't worry, giving you those how does root 3 becomes, how does cos 30 becomes root 3 over 2. We will do it, don't worry. We will do the proving. So that is just that about that. So let's go to another one. So let's say for example we have Let's say we have I'm coming. Let me just check for one. Let's say we have tan question 3. Let's say we have tan 300 degree. Can we all try this guy? So is it not tan? What are you saying now? What are you saying? Now let's try for tan. For number 2, what happened? And you are giving cos. Tan is the one that is positive. So that's why he's having minus. The cos is having minus because tan is the only one that is positive. Sine and cos is negative. That's why he's having minus. And tan is positive. What were you giving? Is it tan you are giving or cos? We are giving cos. So for question 3, what do we have? We have tan 300. Thank you, G. Thank you. So you have minus what? Minus tan 60. So let's do it together. Yeah, Amira. So, but you know you will not put it in decimal. The reason why you are putting it in decimal is because you are using calculator. Sure you get. Don't put it in decimal. But don't worry. How you will know all those tan something? I'm supposed to even give you before solving this one self. I was supposed to have given you before because I didn't mean I'm giving you. We will not be having issue like this. So, how is it cos now? In your lab, where do you see cos here now? You're given tan, you are changing it to cos. Now, this 300 degree falls on which quadrant? It's better you listen now. I don't know why most of you are distracted. This 300 degree falls on which quadrant? What does 300 degree falls? It falls on which quadrant? Fourth quadrant, right? So it falls on the fourth quadrant. Now, on the fourth quadrant, what is positive? You are not changing the what is. You are not changing it to what is positive. You are still going to use what they give you there. Here now, on this 210 now, 210 falls on which quadrant? I've done that one already. 210 falls on which quadrant? On the third quadrant. But what is positive on the third quadrant? Only tan. It means you are giving cos, it will be minus. You are not changing what they give you. You are not changing what they give you. It means you are giving cos. It means on the third quadrant, only tan is positive. It means cos and sine is negative. So you are giving cos, it will be negative. Do you get it now? So you are giving cos, it will be negative. On the second quadrant, what is this 120 falls on the second quadrant? What is positive on the second quadrant? Sine. That is why it is positive. You are not changing what they are giving you. So you get it now. So 300 falls on which quadrant? On the fourth quadrant. What is positive on the fourth quadrant? On the fourth quadrant, what is positive? It's better you listen now. On the fourth quadrant, what is positive? Cos, Abi. So it means this tan will be what? Negative. Tan is negative. So that's why it will be minus tan. Now, how do you now get the angle in the fourth quadrant? I said to get the angle there, it will now be 360 degree minus, what is the angle you are giving? 300. You don't have to stress yourself now. I gave you something in short form. Where are you seeing cos now? So yeah, where are you seeing cos now? Okay, that's what is positive there. So it means that will be minus tan. That will be minus tan. That will give us 60 degree. Minus tan 60 degree. And what is tan 60? It's very, very simple. After this one now, I will go and give you those tables so that you know it also offhand. Sure you get. So what is tan 60? Tan 60 is what? Tan 60 is root 3. So that was minus root 3. So tan 60 is root 3. So I'll give you those tables now so that you can know it offhand also. So I'll give you those tables now so that you can know it offhand also. So tan 60 is root 3. Tan 60 is root 3. Tan 60 is root 3. So now if you press tan 300, what will you have? If you press tan 300, you have minus so. And press minus tan 60 and see if it's the same answer. Press tan 300 and check if it's the same thing as pressing minus tan 60 and see if it's the same answer you get. So is it going to be the same answer? Thank you everyone for tapping. Thank you so much. Who is laughing? Who is laughing? So now welcome back. So it's the same answer, right? So that is just that about it's not hard now. So that is just that about that. So in the exam, you see, when they give you bigger angles like this, you don't know, you don't have calculator in the exam. That's why I'm breaking it down for you like this. That's why you have to know those quadrants in your head. Shey you get? In the exam, you will not be given calculator. The calculator you have is not a scientific calculator. So now, I think that's what is giving us problem. Now let me give you the angles so that you can know it off. Let me give you the angles. I'll give you for sine, I'll give you for 0 degree, I'll give you for 30, I'll give you for 60, and I'll give you for what? 45, and I'll give you for 90 degrees, so you can know it. Please screenshot this, then we'll come back and solve one more example. Please screenshot, then we'll come back and solve one more example. Yeah, one more. It's not easy. Please screenshot, then we'll come back and solve one more example. And 120, yes, these are the most important angles to know. Yes, now, so if you need proving, we'll do proving also. But if you don't need the proving, fine. But if you need the proving, I'll do 1 or 2 proving. I'll not do everything. So just 1 or 2 proving. Then so that you can put it in your head also. So are we ready? Can I clean? I'll give you the important ones. Okay, and 120 also. Mostly you can break 120 down now. You can break 120 down. I'm not giving 120. You can break it down. You can break 120 down. So there's no need of doing 120. Can I clean now? Don't worry, we'll do it. I'll give you everything. Can I clean? Let me give you the angles. Can I clean? Thank you everyone. Thank you so much. Can I clean? Can I clean? Can I clean? Yes, alright. So now I'll give you the major ones you need. Then we can come back. If you want us to still solve more examples, we can come back and solve more examples. So we can come back to that and solve more examples. So now coming to this guy, let me give you for 0 degree, I'll give you for 30 degree, I'll give you for 60, for 45 degree, let me give you for 45 degree, then I'll give you for 60 degree, and I'll also give you for 90 degree. So these are the major ones I will give you. Yes. So these are the major ones I'll give you. So please try and know them offhand. So when you have sine, for sine 0 degree. Oh, how do I do it? Sorry. Let me do it this way. Let me write it this way. Let me write sine here. Sine theta. Let me write cos theta. And let me write tan theta. So now let me give you the angles here. 0 degree, 30 degree. Okay, let me put 60 degrees so you can easily remember. Then 45 degree and 90 degree. Let me write it like this. So for easy remembrance. So when you talk about sine 0 is simply what? Sine 0 degree is 0. On the horizontal, you know 0 degrees on the horizontal. Yes, let me just give you. If you want us to prove, we'll prove, no problem. So on the horizontal, you know, on the horizontal 0 degrees, sine does not have value on it. Okay? So for this guy, we have what? For cos 0 is 1. For cos 0, we have what? 1. Why for tan 0, it is also 0. For tan 0, it is also 0. So if you want us to do it, we'll do the proving. So, but let me just give you. For y sin 30, sin 30 is 1 over 2. Y cos 30 is root 3 over 2. Root 3 over 2. Then y tan 30 is root 3 over 3. That's root 3 over 3. So sin 60 is root 3 over 2. Cos 60 is 1 over 2. 1/2. Then tan 60 is √3. So tan 60 is √3. Why? Cos 45 is √2/2. Cos 45 is √2/2. Sin 45 is √2/2. Cos 45 is also √2/2. Then tan 45 is 1. Tan 45 is 1. Then what for 90 degree? Sin 90 is what? Is 1. Cos 90 is 0. And tan 90 is infinity. So these are everything. I my network around me. Yo, in my network, I'm not seeing comment again. No. Please, someone say something. No. Wait. Okay. We are here. Oh, all right. Why am I not seeing comment here again? Me too. Okay, it's tan 30 degree not 1/3. Yeah, I will explain it. I will explain it. So tan, I thought you people have left me alone now. I thought you people have left me. So you were saying tan 30 is 1/3. Look at it. You know when you have 1/3, in such, what do? You rationalize. You know when you have tan 30, in such, what do? You rationalize. It's not always proper putting square root below. So what do? You rationalize. When you rationalize, you multiply by √3/3. You know √3 times √3 will give us 3. Or you can say √9. √9 will give us 3. So √3 times 1 is √3 times √3 is 3. So that is why it's √3/3. Do you get it now? I'm with you. Alright. Remove. Alright. Okay. So the same thing also for sin 45. I'll do proving for some. Let me just do proving for some. The same thing for sin 45. Sin 45 is also what? Is also 1/2. So, but when you multiply it, you rationalize. It's not always proper putting square root down. So you rationalize by √2/2. So √2 times 1 is √2. Then √2 times √2 is what? √2 times √2 is 2. Or you can say √4. √4 is still 2. So that will give us √2/2. Okay. So let's do proving. So please, these are the major ones you need to know. That's why I say it's very easy. Let me teach you how you can know it. If you know 0 and 90 degree, these ones are not hard. Let me teach you. Are you with me? Let me teach you. Are you with me? If you are ready, say I'm ready. Let me teach you the short thing that you can remember without proving anything, that you can easily remember in the exam. If you are ready, let me know. Oh no, it's not easy. I'm ready. Alright, Rita. Okay, ready. Now let me teach you how you can know it in the exam. Okay. So without proving, let me teach you how you can remember. You know, this is horizontal. This is vertical. This is 0 degree. This is 90 degree. Do you first agree with that? I'm ready. Do you first agree with that? Do you first agree with that? You know, this is horizontal, this is vertical. Do you get it? Yes, okay. So, you know, here is 0 degree, here is 90 degree, right? Now, for this guy, if you press sine, you know, why vertical, this with sine. Now, you see, for you to press sine 0, what do you have? For you to master it now, press sine 0. Hey, is it like I'm lagging or what? Network. Sorry. So I'm looking at it here. Sorry, wait. Is it better now? Yeah, I know I'm lagging. Is it better now? Is it better? Okay, better now. So you see that this is horizontal, this is vertical. I'm coming again, I'm explaining again. This is horizontal, this is vertical. Now on the horizontal, you know this is 0 degree. For vertical, this is 90 degree. Now on the horizontal, you deal with cos. On the vertical, you deal with sine. Oh yeah, just to check, press sine 0 on your calculator. What will it give you? Sine 0 will give you what? It means that sine does not have value on the horizontal, but press sine 0, what will it give you? Yeah, I'm from Lagos, Nigeria. Network. Which one is network? My network is okay now. So you see that sine 0 will give us what? 0. Do you get it now? Sine 0 will give you what? 0. It means on the horizontal, it is only cos that it is recognized. Oh yeah, press cos 0. Check. Press cos 0. Cos 0 will give you what? There's proof, you know, there's a diagram that can explain all these things, but it's going far. So you see that cos 0 will give us what? 1. So that's why for 0, when it's talking about 0 degree, do you get? It is only cos that is recognized. Sine and tan, they are rubbish. Do you get it? So tan 0 is also what? 0. So just know that when it's talking about 0 degree, do you get it? When it's talking about 0 degree, sine is 0, tan is 0. Only cos is recognized. Are we clear with that one? Are we clear with that one? Are we clear? Yes, alright. So please put it in your head. When you talk about sine 0 is 0. It's only cos 0 that will give you 1. Now let's go to 90 degree. We'll come back to these guys. Let's go to 90 degree. 90 degree now. You see that 90 degree is for what? It's for the vertical. So you see that only sine is recognized here. So if you press cos 90, what will it give you? If you press cos 90, what will it give you? Cos 90 will give us what? The camera is blurred, it's not blurred now. You see that cos 90 will give you 0. Do you see it now? No, cos 90 is 0. Cos 90 is 0. It will give you 0. Cos 90 is what? Is 0. G. Check your calculator very well. Cos 90 is 0. Yes. So you see that that's why on the vertical, cos is not recognized. So that's why when you have cos 90, look at cos 90, you have it as 0. Now press sine 90. Press sine 90. You know, it's because your calculator is in radian. Change it to degree. Change your calculator to degree. G. Your calculator is in radian. Change it to degree. Your calculator is in radian. Change it to degree. No, sine 90. Sine 90. I mean sine 90. Sine 90 will give us what? 1. Do you get it now? Do you get it? Sine 90 will give us 1. Armstrong is here. Armstrong, welcome me. Are we all clear now? How will you change it to degree? You click on Z. Alright. There's something you have to click on now. I'm coming. Let me check. So you click on mode. When you click on mode, you click on mode. Yeah, you click on mode. When you click on mode, I'm coming. When you click on mode, you keep on clicking on it. Click on it, you will see degree. Then press number 1. Click on mode, you will see mode. Continue to press the mode. Just keep on pressing it. You will not see degree. Then press the number they put there. Number 1. Press number 1. Then it will change to degree. Your calculator is on radian. So why is tan 90 infinity? Tan 90 is simply what? Is simply infinity. Tan 90 is simply infinity. But let me just teach you How do you get infinity? How do you get infinity? This is how you get the infinity. Look at it. You know tan. What is tan? Tan is what? Sine over cos. Don't forget, tan is what? Tan is what? I'm coming, that's what I'm explaining now. You know, we said tan is what? Another name for tan is sine over cos, right? Abi? Is that not what we said? Another name for tan is what? Sine over cos, right? Yeah, now confirm. Come on. Yes, sine over cos, right? That's another name for what? Tan. So it means, what is our sine? It means if I'm saying tan theta is sine theta over cos theta. What is sine 90? Sine 90 is 1 over what is cos 0? Cos 0 is 0. 1 divided by 0. You know, anything divided by 0 will give you math error. Anything divided by 0 will give you math error. No, it's not complex infinity. Okay, and that one is rich people calculator. So that's why, you know, anything divided by 0 will give you infinity. You can say math error, you can say syntax error. It means there's nothing that can divide 0. Do you get it now? Peculiar, which one is down? Do you understand? Oh my God. Just explaining. See how many minutes it took us. We've not even solved. Cos 0 degree is 1. Yes. Cos 0 is 1. Then sine 90 is sine 90. Oh, sorry. For the tan. Can you hear me? Sorry. Sine 90 is 1. Then cos 90 is 0. Sorry, that was what I was supposed to say. Sine 90 is 1. Then cos what? Cos 90. You know when you talk about tan, sorry. You know when you talk about tan, this is the angle 90 now. Abi? Is this not the angle 90? When you talk about tan, it means the angle there is what? 90. So you get. So that's why tan 90 is what? You know when you're talking about tan, good evening. It means the angle there is 90. When it's tan 90 now. So you get. So that will be sine 90 is 1, then cos 90 is what? 0. Do you get? Rita, do you understand it now? You know the angle now is 90 degree, not those ones. Yes. Do you understand it now? So that is sine 90 is 1, then cos 90 is what? Is 0. So the angle there you are dealing with is 90 degree. The angle there now you are dealing with is 90 degree, not the 90 and 0. So sine 90 is 1, then cos 90 is what? 0. So 1 divided by 0 will give you infinity. So that is that about that. So I've explained 0 and 90 degree now. 0 and 90 degree. Now coming to this guy. Just know that sine 30 is equivalent to what? Just know that sine 30 is equivalent to cos 60. Sine 30 is equivalent to cos 60. While cos 30 is equivalent to sine 60. That's why cos 30 is equivalent to sine 60. This was what we wanted to prove before, where I was saying sine theta and sine alpha, that you said I should not do sine alpha. So it wants to show you that sine theta is equivalent to cos alpha, while cos theta is equivalent to sine alpha. So that is that about that. So remember that one. Sine 30 is equivalent to cos 60. Remember it. So if you remember sine 30 as 1 over 2, you should know that cos 60 will also be 1 over 2. Then if you remember sine cos 30 as root 3 over 2, then definitely sine 60 should be root 3 over 2. And that is that about that. So please put that one in your head. Are we okay? Can we move now? Can we solve other questions and we'll just round up? Are we okay? Yes, 1. Okay. Which one is that one peculiar? Are we okay? So please try and put these things in your head. Try and know it often. Try and know it often. Can we move on? Can we continue? Be my network around again. Can we continue? Yes, okay. So now let's just solve a few more examples then I think we might round up anytime soon. Then we'll come back to bearing and distance some other day. We'll come back to bearing and distance some other time. We'll come back to bearing and distance some other time. Now, look at it. Let's say you are given, take note of this question. Now, let's continue that question without calculator. Let's say you are given this question, cos 390 degree. Now, let's continue those questions we are solving. On my own line, I'm tired. My God. It's like YouTube life is more stressful than TikTok, because YouTube, the delay is kind of too much. The delay in YouTube, because I have to wait before it's not radian. You are not clicking on radian, you are clicking on degree. His calculator is on radian before, so you will click on degree. Degree is 1, so just type 1. After you see, when you click on mode, it is over the degree. Which one are you saying? So please make sure you wait. I'll teach you how you can convert from radian to degree. Make sure you wait before we end the live. Make sure you wait though, so that I'll teach you how you can convert from radian to degree and from degree to radian. So please make sure you wait. I'll teach you. Please make sure you wait though. Make sure you wait. But yeah, now you guys are not talking again. I think my network are gone. Alright. Okay, alright. So now let's see this example. Cos 390 degree. You know, when you are giving cos 390 degree, which angle does 390 falls on? Which quadrant? Does it fall on any quadrant? 390 degree, does it fall on any quadrant? 390 degree, does it fall on any quadrant? No. Do you get it? You know, the angle 390 is more than the 360. Sure you get. So, but wait, listen. Whenever you are giving an angle greater than 360, listen to what I want to say. It's not third quadrant now. Favor, Azar now. It's not third. Whenever you are giving an angle greater than 360, you keep on subtracting 360 from that angle till it falls on the quadrant. I don't know if you get what I'm saying. Sure you get. I'm teaching now. Am I playing? So I'm not playing now. Whenever you have an angle greater than 360, you keep on subtracting 360 from that angle till it falls on the what? Till it falls on the quadrant. Do you get what I just said now? Do you understand what I just said? Oh. Do you understand? I'm not saying you should use calculator. We are not using calculator. We are doing it without calculator. Do you understand what I just said now? Listen now, it's not like you can't hear me. I said whenever you are giving an angle that is greater than 360, 390 is not greater than 360. 390 is not greater than 360. 390 is not greater than 360. You are talk now. 390 is not greater than 360. Is greater now. So whenever you are giving whenever you are giving an angle that is greater than 360, you keep on subtracting 360 from it. So what do? You know, we can't say maybe it is minus or plus. You know, since it doesn't fall on any quadrant, we can't say it is plus or minus. Sure you get it now. Since it doesn't fall on any quadrant, the 390 doesn't fall on any quadrant, we can't say it is plus or minus. So we still call it the cos. Now what do you now say? You now say, oh sorry, you say that angle minus 360, sorry. The angle is now what? 390 degree. So you keep on subtracting 360 from it till you have the angle that falls on the quadrant. So that will be cos 390 minus 360 will give us what? What is 390 minus 360? 390 minus 360 will give us what? 30 degree. Thank you. So that will be 30 degree. That will be cos 30 degree. Now 30 degree, does it fall on any quadrant? You see the angle now falls on a quadrant. 30 degree, does it fall on a quadrant? Which quadrant does it fall on? 30 degree, which quadrant does it fall on? Which quadrant now does it fall on? On the first quadrant. And what do we say on the first quadrant is? On the first quadrant, what do we say it is? All are positive, right? It means cos is also positive like that. Sure you get. So it means on the first quadrant, all are positive. So it means cos is also positive. So what is cos 30? Cos 30 is what? Don't forget cos 30 is root 3 over 2. So if you press cos 390, it will give you 0.866. Press cos 30, it will still give you 0.866. So do you get it now? Do you get it? Do you understand? So let's just solve one more. Then probably, though that's not all on trigonometry, but probably we see what we can do also before we call it a day. So let's just solve one more. Are we clear with this one now? So when you have an angle that is greater, when you have an angle that is greater, when you have an angle that is greater, that is greater, that is greater, that is greater. So let's pick one more. Are we ready? Can we pick one more? Yes. Alright, let's pick one more. So let's say you have sine 1000. Let's say you have sine 1000 degree. Looking at it, it is more than 360 already, right? So looking at it, it is more than 360 already, right? Ah, my God. Looking at it, it is more than 360 already, right? Yes, that's root 3, yes. Yes, root 3 over. So it is more than, so what do? You will say, since it doesn't fall on any quadrant, we can't know if it is positive or negative. Since it doesn't fall on any quadrant, so we can't say it is positive or negative. So we still leave it as sine. So what do? You say 1000 degree minus, you subtract it from what? 360 degree. What will it be? Sine. 1000 minus 360 will give us what? Will give us 640, right? That will be one. You see that you keep on subtracting 360 from it. So 1000 minus 360 will give us what? Will give us 640 degree. Now the 640 degree, does it fall on any quadrant? The 640 degree, does it still fall on any quadrant? The 640, does it fall on any quadrant? No. So what do you do again? You subtract again. So you say sine 640 degree minus what? You subtract it from 360 degree again. So what do you have? That will be sine 640 minus 360 will give us what? 640 minus 360 will give us what? Thank you, 280. So that will give us 280 degree. Now if you look at it, 280 degree falls on which quadrant? What does 280 degree? Does it fall on any quadrant? 280 degree, does it fall on any quadrant? Yes, now 280. No, it's not third. Third is from 90 to 180 to 270. So this is more than 270 already. So the fourth is from 270 to 280 and 360. Do you get it now? So 280 falls on the fourth quadrant. So on the fourth quadrant, what do we say is positive? On the fourth quadrant, what do we say is positive? On the fourth quadrant, what do we say is positive? On the fourth quadrant, what do we say is positive? No, it's not tan, it is cos. So it means the sign now will be what? You see that the sign now will be negative. That was how you now say minus sign. So how do you get the angle in the fourth quadrant? You say 360 degree minus 280 degree. So what do you have? That will be minus sine 80 degree. And that's the final answer. That will be minus sine 80 degree. And that's the final answer. Do you get it now? Oh yeah, press sine 1000 and press minus sine 80. Let's check if the same answer. Since we don't have value for 80 degrees, so let's leave it like that. Press sine 1000 and press minus sine 80. Let's check if it's the same answer. Check. God. Is it going to give you the same answer? Is it going to give you the same answer? You see that it's the same answer, right? So you see that it's the same. So because we don't have a angle that we can easily relate it, let's just leave it like that. So you see that is just how you solve questions on this guy. That is just how you solve questions on this guy. So please permit me to call it a day here. The reason why was I didn't eat before coming live. That was why. So that's why I feel kind of weak. So please permit me. So don't worry, probably we'll round everything up on TikTok again. Probably next week or anytime. So we see tomorrow on TikTok. I'll just come live on TikTok tomorrow. Alright, so I'll come live on TikTok. So as the spirit leads, we'll do physics, or if I have the strength, I will come. If I don't have, then till Monday. So we might finish the rest on Monday, or I don't know, anyhow the spirit leads. So majority people did not know I'm here. So they did not know I come to YouTube. So even though I told you people that I was coming to YouTube, so majority did not know. So that is that about that. Thank you everyone. The taps is okay. Thank you. I appreciate it. The taps is okay. And YouTube self, the way the network is even more stronger than TikTok. And the seconds lagging is actually even somehow. So please, thank you everyone. So wait, before you go, I said I was going to show you conversion. Wait. Some people have gone already. Wait. Some people have gone already. Let me show you conversion before you go. Please permit me to show you conversion. So this is it. Look at it. Oh, sorry. When you look at it, my TikTok page. Can we all see it? Can you see these 3 pin videos? Can you see the 3? Yeah, I know they forget though. It's better now, so that even if I don't touch it again. Can you see the 3 pin videos? Yeah, now talk to me now. People have gone already. So you see this playlist. Swipe to the left. Click on view all. Now go down. Look for did I even do it safe? Wait oh, did I even do it? I'm coming. Alright, was it on my YouTube page? I'm coming now. I'm trying to check, maybe it was on my YouTube. Where did I not do this thing? Conversion from degree to radian. Okay. Let me check. I'm coming. Please, 1 minute. Did I do this thing? So please wait. Hold on. Okay, maybe this is it. When you get there, you see this conversion. You see this conversion of cadential to polar. Conversion of cadential to polar. Click on it. Then you see how you can convert from degree to radian and from radian to degree. From degree to radian and from radian to degree. So please make sure you know it. It's part of trigonometry. So make sure you know it. From degree to radian, just look for conversion of cadential to polar. that is from degree to radian. So please make sure you go through the video. It's on my TikTok page. Just go to my TikTok, click on it, but make sure when you click on it, make sure you like and share. Like and share. Abby, sorry, Radiant. So alright, thank you everyone, and have a good night rest. So the major part, we didn't actually do the major part, which was the when sin theta can come. But don't worry, next time, maybe next week, we'll find time and do it on TikTok. So I wish you all good night rest and have a good night rest. So take care of yourself and sleep tight. Take care of yourself, everyone. Take care of yourself and have a good night rest. Alright, good night, good night. Please go, 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 go. Go, go, go. Chiffon, thank you. One Bonnet, thank you. Amira, thank you. Peculiar, thank you. Thank you, everyone. Radiat, thank you. Rita, thank you so much. Alright, so we see on TikTok. If I have the strength, I'll come. Dubem, thank you so much. Delight, Rita, thank you. So, Cassandra, we had this bit. Thank you, everyone. Thank you so much. Thank you for coming. Thank you. Thank you, thank you, thank you. Have a good night rest. Bye bye. Bye bye. Go, 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 go. Alright. Bye bye. Good night. Go, 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 go. Why are you laughing, Godwin? Rita. Yeah, go now. Alright, Eniola, thank you so much. Good night. Take care of yourself. Good night. Alright. Roski, thank you. Roski, thank you. Good night. Good night. Bye bye. Amira, Godwin, go. Go, 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 go.